to waste, so please be quiet. Okay, this time we will start differently. We will start by having a quiz. Please be quiet such that we can start. Have your laptops ready? So we'll have our second quiz. This time Dropbox in Avenue is working, so you will be able to submit your Dropbox once you are done. This time we should be more organized, so please no one comes forward. Remain seated. Once you are done, submit it. And after the time is over, I'll ask you just to be done, and that's it, right? Afterwards, we'll solve the problem. So if you have any question with regarding to the quiz, you will see the solution afterwards. Good? Okay, so let's start. What you are required to do in quiz 2 is basically you will ask the user to input a sequence of 20 integers, and then what you will do is you will store these things in an array and determine if the sequence is sorted in a non-decreasing order. So you will display a message saying your sequence is sorted or your sequence is not sorted. Is that clear? So time now is 10:36. And you guys have 10 minutes from now. So we'll be done in 10:46. Please go ahead and start. Yeah. Would you please raise your voice? Non-decreasing order means any number that comes as an input from the user shouldn't be less than the number that was the numbers that were previously entered, right? So non-decreasing is different than increasing. I shouldn't explain these things, you guys should know, but basically non-decreasing order means each time you enter a number that is not less than whatever the user has already entered, right? Yeah. Where is? Once you are done, you'll be able to submit. Yeah, it will be on Avenue. Yeah. I just make it visible right now. The last thing I thought you will have a problem with. Non-decreasing order means it's non-decreasing, right? Any number that you enter is not less than anything that you already entered, right? Why? Okay, is non-decreasing equal to increasing? Why saying non-decreasing, not increasing? Because they are not completely equal, right? And you should think in this special case. Now I have the 20 elements in the array. Good. I need to go through the array one by one and check whether it's satisfying the condition or not. But because you are in a loop, you need to remember somewhere whether at any condition checking you violated your condition or not, which is non-decreasing order. Then we find a flag that we set as 1. We will see what 1 means or 0 later, or flag of 1 or 0 means later. But let's do what we already know. We have a loop of 20 iterations, and then each time we ask the user to input something. Last time we did this exactly by storing each input to one element array, one element of the array, and then because you increase the index, each time you store in a different location. Good? First time you store an index 0, and then 1, 2, until you get for the 20th location. Now we have read the 20 elements in the array. What you need to do now is, I need to go through the array and check whether I satisfy my condition or not. You need another loop. I guess as you can expect, what is the limit of your loop here? Yeah? 20, right? Because you need to go through the 20 elements again. So this is exactly similar to this one. And then, if the current item is larger than the next item, then flag is 0. What does that mean? The user inputted something. So let's try to imagine this. So now I have the 20 elements in the array. Good? I'm going through them one by one. Remember that the one that the user inputs first is actually in index 0, right? So if the user inputs 1 and then 2, 2 is larger than 1, this is an undecreasing order. So this satisfies the condition. If the user inputs 1 here, now I violated my condition, right? So what this states here is basically if the current item is larger than the next item, so if I'm here, and this is larger than this, that means this is not an undecreasing order, right? Because you have 2 and then 1. You actually decreased, so you didn't satisfy the condition. This is why we set the flag to 0. So flag 0 means the array is not sorted. Good? Flag 1 means it's sorted. Each time, any time you violate this condition, so something like that, you go from 2 to 1, for example, then your flag will be 0. And that's enough to say you already violated your condition. The flag will remain 1 until the end of the 20 iterations only if it's actually an undecreasing order, right? Only if each item or each integer the user inputs is larger than the one it enters before. Good? Great. So if AI is larger than AI plus 1, then flag is 0. An example is here, like element 1 is actually larger than 2. That means the array is not sorted as it intended. Good. But because I do it this way, each time I actually access 2 elements, which is 0 and 1, for example. Like if I is 0, I check 0 and 1. That means if I go to the last one, if I do it from 0 to 20, or like less than 20, which is 0 to 19, if you come to check this one, you will have an error first. Second, this is not needed in the logic. Why? Because the last one is not compared with anyone afterwards, right? So you need to stop in the last but 1, right? You need to stop here because you need to check element 19. That's why I made my limit to 19. Is it wrong to have the limit to 20, but do it in a different way to check? It's not wrong. There are multiple ways to do this example, right? Yeah, what I'm writing here is the number of, like basically this is element number 19, which is indexed by 18, because you start from 0. So, yeah. Another way to do this is actually check the entry or the index with the one that is before it. And in this case, it's okay to go to 20. Any way to do it is correct, right? And then after you are done with your loop, now you need to check your flag, right? If flag is 1, then the array is sorted, because anytime you violate your condition, flag will go to 0. That means if it remains 1 until the end of the number of iterations, then you are good. Otherwise, the array is not sorted. Good? Great. This is why we started the flag with 1. Okay. Is there another way to do that? Yes, because basically, if logic, after you violate your flag for 1 time, actually there is no need to continue the number of iterations, right? For example, here, I violated my condition. So I know at this point that the array is not sorted anyway, even if it doesn't really matter. So there is no way to keep it, right? So what we do next, and this is kind of a running time optimization. Think of if you have, instead of 20 elements, 20 million elements. Once you find out you are actually not sorted, you violated your condition, why I continue doing 20 million iterations, right? So what I do here is I put another condition in the for loop to check if the flag is still 1, because if the flag is 0, there is no need to continue, right? Can you think of a different way of doing this? Instead of putting the condition in the for loop itself? Yeah, use a break statement. Please give me your name after the lecture. So basically, instead of doing that, what I can do is, if I violate my condition, then I just break. We have covered break last time by saying once you break, you actually skip the full number of iterations, right? The remaining ones. It's exactly the same thing as the previous one, right? As you can see, there are multiple ways of doing things. Actually, this way is more elegant than the other one, because people tend to have the condition in the for loop to be simple, only one condition, not and multiple things. This is not a good way of writing for loop. Is that clear? Question, yeah? Here? Why we did this? Oh, you already did that? Yeah, that's a correct. Yeah, this is a correct solution. That's actually an optimization. Even if you do this and you keep checking the remaining ones, that's also still okay. This is only an optimization, right? That's okay. Unless I ask you in the exam or like in a quiz to do the minimum running time or minimum space or these kind of things, then it's still okay to keep doing the iterations. Okay, any question with regard to this question? Good. Okay, so today we're going to cover functions. We will come back to arrays later to get more advanced topics, but for now we can utilize arrays in our questions like in an easy way. Arrays are actually easy to handle, forgetting about like the tricks that we will see later. But basically functions. Why do we need functions? Any idea? So far we have been able to write programs in a good way. Yeah. Modularity is one thing, that's true. Any other reason? Yes, so yeah, similar to modularity but in a different way, that's true. Basically what it's saying is if you run the same set of code multiple times, then maybe you just define it as a function, then you keep calling it instead of doing it multiple times. Same thing similar to modularity. Usability is one thing. Integratability, because you write one piece of code, assume that you work in a company, and then you have a big project. No one actually does the full project on his own, right? You take one module, you try to test it in a standalone fashion, you do your best effort to get it working, but then later you need to integrate this into the remaining modules to get the full picture of the project, right? If you don't write your code in a good modular way, and then you don't define it, later we will see classes and these kind of object-oriented things, but for now, let's talk only about functions. If you don't define it, for example, as a function, how can you integrate, like let's say, 100 different main functions together? You cannot have more than one main in a C program, right, in a project. So how these things will work together? Basically, there will only be one that is responsible for integration. This is the one that defines the main file, and then every one of you will actually write, let's say, a function. And then later these things will work together, right? Good. So this is what we cover from the references if someone is interested in reading. Yeah, another thing that I forgot to mention is actually, I don't know if you see this in Avenue or not, but maybe every week or two, I put, aside from the labs and lectures and tutorials and these things, I also put some practice questions for the topics we cover so far. So for repetition loops, if conditions and variables and these things, I have put, currently you have 2 set of practice questions. Later, if you are interested, I can also post the solutions for that, but I would like to give you more time to actually try this on your own. This is another mean for you to try different things, see maybe how the questions in the exam would look like, try to write some program on your own. So it's a good practice for you, in case you have some time after doing the lab. Good. We discussed all of that. So in C, to define a function, you need actually to do 3 things, right? So what are these 3 things? We said you have only one main. And the program execution, as we discussed in the first lecture, starts actually from the main, right? Assume now that I need to define a function. Do 3 things. First thing is the function prototype. The second thing is, let's say, keep this, the third thing. And then the second thing is actually the function body or definition. And then the third thing is function calling. And actually I put this place here for a reason, right? The rule is you cannot actually call a function. Function calling is actually when you use it, right? And we will see some examples just right now. Basically, you cannot call a function without having a prototype for it, right? Prototype is not the function implementation. Prototype is just, you can think of this as the syntax of the function, how to call it, right? But the function implementation itself is what we call the function body or definition, as far as you have the prototype. It may sound confusing, so let's see one example, right? Assume that I have a main here, and this main is using a function that is called my mean square. So it takes two inputs and then returns the mean square to you. This is the function call, right? You are calling the function to use it, to perform certain operation. To be able to do this, you actually have to implement the code that does a square mean, right? So this code is what we call function body or definition. Basically, it takes two inputs, x and y, and then it gets the square mean and return z, which is the result, right? But then, if you just write this in any compiler, it will give you an error. The reason is, C compilation process starts from the main, as we discussed before, and goes line by line, right? I'm a compiler right now. I don't understand what you intend to do, right? So I started from here. Here is okay. Here, I actually encounter a function that is called my mean square. But I don't have a function in studio.h that is called my mean square. This is undefined function, right? So I give you an error because I don't know what's going to happen later. To avoid this, you have actually to give a hint to the compiler, what we call the function prototype, that you are going to use later a function that is called my mean square. And this is the purpose of having a prototype before the calling of the function, right? How the prototype looks like, if you look here, it's actually exactly the same line, the same first line of the function definition. This is composed of what is the return value, the name of the function, and the input parameters to this function. Right? So this function is going to read or take as an input two variables, perform some operation. This is the name. This name has the same rules as any variable name you can define. And then you return a value of double. Good? Then if a function has a return type, then you have to have a return statement at the end. Because otherwise, what should I return? Right? Good. So this is basically the syntax of defining function definition. As I said, the return value, the name, the input parameters, and this is the code that implements the function itself. If you don't have a return, value, don't want to return something similar to what I have written for the main here. What should I do? You should put a void here, which means you return nothing. So it's okay not to have the return statement. Good? So one important point, if you go to the mean square thing, is here in the main, I'm actually passing some inputs to the function itself. Please pay attention to the order, right? So basically the first one in the call will go to the first parameter in the function definition, the second one will go to the second. For example, if this is double and this is, let's say, a character, the second one has to be a character. So the type has to match, right? Good. Any questions so far? Yeah. Great. So yeah, so this is another way of doing things. So I told you that the purpose of the function type is to tell the compiler that you are going to have a function with this name, such that when you come to call it, like the compiler will recognize it, so it will not give you an error. Good. If you take the full body and put it before the main, or in general, before the first time you call the function, this is also okay, right? It's actually not a very good programming skill, because that means before the main you're going to have a bunch of, like maybe hundreds of functions, which is not good. Later we will see how to modularize our code, define things in a different header and .c files. But from a syntax, from the compiler, that's correct. So what you can do here is take the full body, put it before the main. Now you don't need a prototype. Good? Okay. So another rule that is very important here is actually the function definition, which is this code, has to be outside of any other function. You cannot define the function inside the main, right? So the function, because functions are global things, you should be able to call them from any other function. If you put them inside a function, intentionally this actually doesn't have a meaning, right? So the compiler will give you an error. There was a question here. You mean as, okay, that's an important question, right? And not because of the question itself, it's because the way you asked it. This is not the data type of the main. This is the return value of the main. Good? So you have to differentiate. If you put an int in front of a variable, it's completely different than putting an int in front of a function. Int x, that means this x is a variable with a type of int. Int main doesn't mean that the function main has a type of int. It means it has a return value of int. Good? This is the first important thing. It's not related directly to your question, but that's very important. But basically here, here I had it as a void, which means I return nothing, right? But usually people define int main because at the end they want to return 0 if you have no error. So usually you say return 0. This is basically a programming convention by saying if your code completes until the end, you return 0, which means I receive no error. But again, it's still okay to say void main and then you return nothing. Good? But aside from the main, you can actually have any type of return value. You can return a character, a double. As we will see later, you can actually return a pointer to another function. Right? Good. Any other question? Okay. This is a prototype we discussed. This is the function call we already discussed. Okay, good. This is basically a walkthrough example to understand what is going on when you define and call a function, right? So here we have a main, and this main again is using my main square. And then I define my main square below the main, assume that I already have above the main. Good? What happens? Let's see one by one what happens. At the beginning, I'm starting my program. Here. Afterwards, I execute the function called, which is my main square, and then pass a to x and b to y. The important concept to understand here is actually you are not passing a itself. So it's very important to understand. If this is your memory, and you define a as a variable, as an int, then, as we stated before, you store 4-byte or reserve 4-byte storage, and then a is referring to this, right? The same thing for b, it's referring to this. Why it's 4-byte? Because it's an int, and the int is 32 bits, right? Good. Then later, you pass these two to a function, it's called my mean square, that takes x and y as ints, right? So you are not, basically the function which is my mean square is not going to use these two locations. It's going to define two different locations that we called x and y. And then when you call the function, the value from here, which is 10 and 20 in this case, will actually get passed to x and y. We call this pass by value, right? Later we have what we call pass by, does anyone know? Pass by reference, that's good. And by pass by reference, the different thing here is actually now you are going to use the same location rather than defining a different location. Good? It's a big difference, as we will see later. And let's go through this example. For now, we'll cover only pass by value because this is the basic one. But then later we'll see by pass by reference. Good. So we have 10 and 20. Then once I call the function, x and y, we call them local variables. They get defined, they get constructed in memory once you enter your mean square function, right? Before this, they didn't actually exist in the memory. And we will see what we mean by local variables later. So I define x and y locations and then z, because this is my return value. And then in calling the function, the value itself will get copied from a to x, and then from b to y, right? Y not from a to y. For example, why not y is 10 and x is 20? Yeah? This is the order of your parameter passing input, and this is very important to know, right? Good. And then you execute your function code. You basically take the mean square, and then what I do here is basically squaring a. So as you can see, I'm changing the x, but a remains the same. squaring y, get the z value, and then later, once you are done with your function execution, and you go back to the main function, before this you have this return statement, which is basically returning the value itself. Where should I return z? This is the variable that is going to take the output of the function, c, right? So basically c will get a copy of the z value, right? The thing that is very important in passing by value is after you execute your function and return to the main, a and b remain the same. They didn't change, right? So a is still 10 and b is still 20. X and y change it, but then not a and b. Good? This is one thing. The second thing is, as you have seen here, once I am done with the execution of the function, all the local variables get destroyed from the memory. Good? So once my call to my mean square function ended, I no longer have x, y, z in the memory. Right? These places are destroyed. This is another good thing about using functions other than modularity, is actually you optimize your memory storage. Because by defining local variables, you only define them and use them when you need them. Once you are done, they get destroyed from the memory. So you don't basically have huge memory utilization that is not needed. Any question? Okay. Okay. So this was related to his question here that's saying, why do I need to define the type, right? Can I just take the body and put it before the main? This is an example of doing that. You can take the full body of the function, put it before the main, and here you can actually use your max without having a prototype, because basically a prototype is just a part of the body. So if you take the full body before the main, then you are still good. Good? Okay. This is an example of another, basically this is just another function. It's completely covering the same concepts. What we do here is we find the max of two numbers, right? Using the conditional operator we covered before. So here I'm basically passing a and b. And the good thing that I'm trying to do here is actually I'm displaying the value of a and b before calling the function. And if you repeat this line later, you will see also that a and b actually didn't change with the max, right? Good. Now comes to a very good programming skill concept, which is, assume you have a very big program like the example that I gave earlier. You have hundreds of functions. Am I going to actually define them, write the body completely in one file before the main? This is going to be completely messy, right? What should I do? Is actually utilize the same way we are using the header files from the C library, right? We use print as a function, but we never have seen the actual implementation of the printf in our file, right? How does the compiler know to execute printf? Because we included the studio.h header file. The studio.h, the only thing that it has, it doesn't even have the implementation of the printf. It only has the prototype of the function. And this is the purpose of having header files in C. Header files only in .h files include only the prototype of functions, right? And some global variables. Good? And then you have another file which is called studio.c, which has the actual implementation of the function itself. So comes to our case, my mean square function, for example. You can define a header file that you call, I don't know, mymath.h. And then you define another file that you call mymath.c. In this one, you put the prototype of my mean square function. So you say, I don't know, like double my mean square, and then you take the inputs, and then that's it. You are done. You don't define anything else. Here, you define the actual body of the function. If you go to your main file, which is your program.c that has the main function, what should you do to be able to use my mean square function? Yeah, include only the header file, similar to what you have done for printf and studio.h. Good? So this is a modular way of actually having your program in a good organized way. Is you define your own header files, your own function C files, and then you have the main C file that includes all the header files. Good. I assume that basically this is my math.c file where I define my add and my sub. So basically I define my own addition function, my subtraction function, both in a. And then I need another header file that has the prototypes. If I go to the main, I need to include my math.h file. Good. And then now I can actually use my sub and my add functions in the main. Good. I guess this is actually much more organized way than defining the full body of the functions on the same file, especially if you have large projects. This makes sense? Do you have any question? Yeah? No, in my math.c you don't put the prototype, you only put the implementation. Sorry, what is the question? Yeah, so you have two files for your function. The header file, which includes only the prototype, similar to what we have here. And then you have the math.c, which has the body or the implementation. They are not the prototype is not the same thing as the body. The prototype is only, as you can see here, the first letter that defines how you call the function, right? So if you have further questions, please come back. So we are done for today. Thank you so much.
Like the .h.c files, obviously they have to be stored somewhere.
Yeah. That's true.
Where does it have to be?
Yeah, I didn't mention this. Basically, what we have written, extension, or put any directory for the file, that means it's in the same folder or the same